Good morning to everyone. Today, my group, Hazel Silas, Rosalie Go, and myself, Jihan Nubi, are going to present our topic, STS, Ozone Depleting Compounds. Our objectives include to be able to know what is the ozone, to be able to know what are the ozone depleting compounds, to be able to know the impact exposure to UV has onto the environment and society, and also alternatives to ozone depleting substances.
What is ozone? Ozone is a highly reactive gas composed of 3 oxygen atoms. It is both a natural and a man-made product that occurs in the Earth's upper atmosphere and lower atmosphere depending on where it is in the atmosphere. Ozone affects life on Earth in either good or bad ways. The ozone layer absorbs most of the sun's harmful UV rays. This radiation causes skin cancer and cataracts. The ozone layer plays an important role in protecting human health. It also prevents radiation damage to plants, animals, and materials. UVA, UVB, and UVC. UVA is a low-energy form of UV and has only minimal biological effects. UVB, a higher energy form, causes the most damage to living organisms and materials. UVC is absorbed by the oxygen in the atmosphere and never reaches us. Ozone layer depleting. In 1970s, scientists noticed that the ozone layer was thinning. Researchers found evidence that linked the depletion of the ozone layer to the presence of chlorofluorocarbons or CFCs and other halogen sources gases in the stratosphere.
As you can see here, the Earth shaded in blue colors shows the ozone depletion in the southern hemisphere in 2006.
Ozone depleting compounds. Do you know what ozone depleting compounds is? Ozone depleting compounds are chemicals that destroy the Earth's protective ozone layer, which increase UV levels. Chlorofluorocarbons or CFC, halons, halogen gas, and hydrochlorofluorocarbons or HCFC. It increases UV levels in the following ways. Destroy many ozone molecules in the stratosphere. This makes the ozone layer thinner. Thinner ozone means a larger amount of UV reaches Earth, particularly UVB. When chlorine and bromine atoms come into contact with ozone in the stratosphere, they destroy ozone molecules. One chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. Chlorofluorocarbons or CFCs. CFCs are non-toxic, non-flammable chemicals containing atoms of carbon, chlorine, and fluorine. They are used in the manufacture of aerosol sprays, blowing agents for foams and packing materials, as solvents, and as refrigerants. CFCs are classified as halocarbons, a class of compounds that contain atoms of carbon and halogen atoms.
CFCs can be found in refrigerators. Most refrigerants found in air conditioners, refrigerators, and freezers contain fluorocarbons, and many fluorocarbon compounds contain chlorine. Chlorofluorocarbon or CFC refrigerants were commonly used in equipment manufactured before 1995. Aerosol spray. Till the 1980s, chlorofluorocarbons were predominantly used as propellants in these liquefied gas aerosols. While CFCs have indeed been largely phased out, aerosol spray cans still remain in use as other suitable replacements have been found for the propellants. Aircraft halon have an extremely high potential for ozone depletion. They are 10 times more potent and they act as a global warming agent 3,500 times as potent as carbon dioxide.
Hydrochlorofluorocarbons or HCFC. HCFC are compounds that contain any of several simple gaseous compounds that contains carbon, chlorine, fluorine, and hydrogen. While HCFCs contain chlorine atoms, they are less damaging to the ozone layer because they also contain hydrogen atoms, which causes them to break down in the atmosphere faster. HCFCs are currently being phased out in favor of HFCs, which do not contain chlorine. HCFCs were used in a wide variety of applications, including refrigeration, air conditioning, foam blowing, solvents, aerosols, and fire suspension. Halons. Halons, chemical compound formerly used in firefighting. A halon may be any of a group of organohalogen compounds containing bromine and fluorine and one or two carbons. The effectiveness of halons extinguishing fires arises from their action in interrupting chain reactions that propagate the combustion process. Because of their bromine content, halons can destroy ozone molecules very effectively, thereby contributing to the depletion of ozone and the creation of holes in the ozone layer of the stratosphere. Many aerosol propellants contained CFCs before international agreements limited their use. Carbon tetrachloride, methyl chloroform. Methyl chloroform is a colorless liquid with an ether-like odor. It is used in degreasing, as a solvent and spot cleaner, and in making other chemicals. It damages the ozone layer. When they break down, they release chlorine or bromine atoms, which then deplete ozone.
Carbon tetrachloride is most often found in the air as a colorless gas. It is not flammable but does not dissolve in water very easily. It was used in the production of refrigeration fluid and propellants for aerosol cans, as a pesticide, as a cleaning fluid and degreasing agent in fire extinguishers and in spot removers. It is a known air toxin and it eats away at the ozone layer. The gas accounts for about 10 to 15% of the ozone depleting chemicals in the atmosphere today. As a result, production across the globe has been banned for many years for uses that results in carbon tetrachloride escaping to the atmosphere. CFCs and HCFCs in refrigeration, air conditioning, foam, and other products. Halogens in fire protection systems, methyl bromide for treating pests in soil, and carbon tetrachloride in chemical processing. Do you think there is a connection between the ozone hole and global warming? Human activities cause ozone depletion and global warming. Ozone depletion does not cause global warming, but both of these environmental problems have a common cause: human activities that release pollutants into the atmosphere, altering it. Global warming is caused primarily by putting too much carbon dioxide into the atmosphere when coal, oil, and natural gases are burnt to generate electricity or to run our cars. Think of what exposure to UV has to humans and the environment. Impact of UV to humans. Sunburn is caused by too many UV rays, which causes prematuring effects like skin wrinkling and hardening, blotchiness, loss of elasticity, dark patches, age spots or liver spots, precancerous skin changes called actinic keratosis. Examples of skin cancer. Solar UVB exposure is the major environmental risk factor in skin cancers. As you can see in the images, this is what happens to your skin if you are exposed to solar UVB for a long period of time. Impact of UV to humans also include eye damage. Too much exposure to UV rays may cause painful temporary injuries to your eye, and it can prematurely age your eye lenses, causing clouding of the lenses or cataracts, non-cancerous growths of tissues, loss of vision, and cancer of the eyelid. Impact of UV to humans also weakens the immune system. The immune system, which is your body's natural defense against disease, can lose its ability to resist bacteria, which increases your risk of infection. But on the other hand, there are some benefits of UV radiation, such as vitamin D production and treatment of skin conditions. Impact of UV to the environment. Damage to marine food chain and food stocks. UV can damage early developmental stages of fish, shrimp, marine mammals, and other fish organisms. Higher UV reduces production of phytoplankton, which is the primary element in food chains and oceans. UV can alter plant development, plant diseases, how nutrients are distributed, and biogeochemical cycles. UVB causes cancer in domestic animals similarly to those observed in humans. Although most animals have greater protection from UVB because of their heavy coats and skin pigmentation, they cannot be artificially protected from UVB on a large scale. Eyes and exposed part of the body are most at risk. Increases in UVB radiation could affect terrestrial and aquatic biogeochemical cycles, thus altering both sources and sinks of greenhouse and chemically important trace gases, for example, carbon dioxide, carbon monoxide, carbonyl sulfide, ozone, and possibly other gases. These potential changes could contribute to biosphere-atmosphere feedbacks that mitigate or amplify the atmospheric concentrations of these gases. Impact of UV to the economy. Increased health costs are the most important direct economic impact of increased UV radiation. The medical expenses for millions of additional cases of skin cancers and eye cataracts pose a challenge to healthcare systems, particularly in less developed countries. Increased UV radiation also produces the lifetime and tensile properties of certain plastics and fibers. Indirect economic impacts include a range of additional costs, for instance, for combating climate change as a result of reduced fish stocks.
Alternative to ozone depleting compounds. Commercial refrigeration, alternative to CFCs for new commercial refrigeration equipment, includes HCFCs. Retrofit or existing equipment is possible by using both HCFCs and HFCs. In conjunction with reduced charges and more efficient compressors, hydrocarbons are, to a small extent, applied hermetically sealed systems. Domestic refrigeration to refrigerant alternative are predominant for the manufacture of new domestic refrigeration. HCFC-134A has no ozone depletion potential and is non-flammable, but it has a high global warming potential. Electronics cleaning experience has confirmed that for most uses in the electronic industry, ozone depleting solvents can be replaced easily and often economically. A wide choice of alternative exists if technical specifications do not require post-solder cleaning. No clean is the preferred technology. Solutions to ozone layer depletion. Avoid using ODS. Reduce the use of ozone depleting substances. Avoid the use of CFCs in refrigerators and air conditioners, replacing the halon-based fire extinguisher. Minimize the use of vehicles. The vehicles emit a large amount of greenhouse gases that lead to global warming as well as ozone depletion. Therefore, the use of vehicles should be minimized as much as possible. Use eco-friendly cleaning products. Most of the cleaning products have chlorine and bromine, releasing chemicals that find a way into the atmosphere and affect in the ozone layer. This should be substituted with natural products to protect the environment. Use of nitrous oxide should be prohibited. The government should take actions and prohibit the use of harmful nitrous oxide that is adversely affecting the ozone layer. People should be made aware of the harmful effects of the nitrous oxide and the products emitting the gas so that its use is minimized at the individual as well. Environmental law to regulate ozone depletion. Clean Air Act, CAA, U.S. federal law passed in 1970 and later amended to prevent air pollution and thereby protect the ozone layer and promote public health. The Clean Air Act, CAA, gave the Federal Environmental Protection Agency, or EPA, the power it needed to take effective action to fight environmental pollution. The CAA was expanded from its original set of guidelines, in which the states regulated the source of air pollution, to the establishment of national regulatory programs with specific air quality requirements, federal enforcement, and federally issued permits which required large industrial entities to address and control their contributions to air pollution. The CAA amendments also set requirements for the banning of chlorofluorocarbons and halon, stop the depletion of Earth's ozone layer, and comply with the Montreal Protocol, which set international guidelines to reduce ozone depletion. Fines may be levied against those individuals or businesses that do not CAA standards. The CAA amendments legislated criminal penalties are potential jail time of up to 15 years for those who knowingly violated CAA standards, along with fines up to $250,000 for individuals and $500,000 for corporations for each violation. The Department of Environment and Natural Resources or DENR said that Philippines has made significant strides in complying with the Montreal Protocol, a 29-year-old global agreement to protect the ozone layer, finalized in 1987. The international treaty legally enforces the phase-out of the production and use for ozone-depleting substances or ODS, or chemicals often used in refrigeration, air conditioning, for manufacturing, aerosol production, and fire extinguishing. As a part to one of those most successful and effective environmental treaties ever, the country agreed to the gradual phase-out of ODS, particularly chlorofluorocarbons or CFCs and hydrochlorofluorocarbons. The Philippines imposed a ban on the importation of CFCs and HCFCs in 2010 and 2013, respectively.
These are the principal steps in the depletion of stratospheric ozone. Step number 1, emissions. Halogen source gases are emitted at Earth's surface by human activities and natural processes. Step number 2, accumulation. Halogen source gases accumulate in the atmosphere and are globally distributed throughout the lower atmosphere by winds and other air motions. Step number 3, transport. Halogen source gases are transported to the stratosphere by air motions. Step number 4, conversion. Most halogen source gases are converted in the stratosphere to reactive halogen gases in chemical reactions involving ultraviolet radiation from the sun. Step number 5, chemical reaction. Reactive halogen gases cause chemical depletion of stratospheric ozone over the globe.
Our category sections are: for the background, what is an ozone? For the context, ozone depleting compound, impacts, the effects ozone depleting compounds, and for our alternatives, other options to replace the technology.